Okay, today we're going to be talking about percentiles, and as an example, we're going to talk about having an exponential distribution, and here the mean is beta equals to 1. We want to calculate the 85th percentile. So just one thing to note is because we're told the mean beta is 1 and we have an exponential distribution, that means that the density function is going to be 1 over beta times e to the minus x over beta, which will just be e to the minus x for x greater than 0. So the keywords here, exponential, were really critical to provide us with the density function. So that's one thing that I want us to remember. The second is that the definition of the pth percentile means that the point P has the kth percentile if it satisfies this property. Okay. So the point P is called the kth percentile. Here we are given that K is equal to 85%. And our goal is to determine the point P that satisfies this property. So we have the probability X is less than or equal to P, and technically that should be less than or equal to, here it won't matter, is equal to 0.85. Because we know the density function, we know that this probability is calculated with the integral from 0 to P of f of x dx is equal to 0.85. And since we know the density function, we'll put in e to the minus x dx is equal to 0.85. We anti-differentiate this, and we're going to get minus e to the minus x evaluated at 0 and p is equal to 0.85. And now we'll plug in minus e to the minus p double negative is equal to 0.85. And now we'll have minus e to the minus p is equal to minus 0.15. So e to the, excuse me, let me change that. E to the minus p is equal to positive 0.15. And at this point, we're just going to solve for p. Okay, and p is going to be minus this ln of 0.15, and that's going to give us approximately this number. And I think it'll be 1.897. Okay, so that is the pth percentile here. Let's just try one more exercise. Okay. And our goal is to find the median of the density function f of x is going to be equal to 3x squared if x is between 0 and 1, and it's going to be 0 for all other values. Well, this keyword, median, has special value. It means half of the data is below, or in other words, is the 50th percentile. Meaning that the probability x is less than or equal to the point P accounts for 50% of the data, 0.5. Well, we're given the density function here, so we're just going to integrate it. 0 to P of 3x squared is equal to 1/2. We anti-differentiate, we're going to get x cubed from 0 to P is equal to 1/2. P cubed minus 0 is equal to 1/2. And so that tells you P is going to be 1/2 to the 1/3 power. And that should be about 0.793. Okay, and so with this density function, the median is 0.79. Okay, so those were just a few examples of calculating percentiles with probability distribution functions. Thank you very much.